In this video, I'm going to show you what the badge does first, with a bit of explanation, and then give a brief overview of how to flash the Raspberry Pi Pico and briefly walk through the code used to get there. As you can see, when the button is pressed, first it picks a random number between 4 and 11 to determine how many times it will go through a loop that picks a random number for each die and displays it. The code then pauses for 4 seconds to let you read the results, and then returns to Lucky 7 mode, where it steps through combinations of how to get a pair of dice to add up to 7. The code is also toggling pin 7 on and off to provide the input signal needed for the decade counter on the SAO. You will need to install the Thonny IDE on your computer or use the one in the Maker's Village. I'll leave a link to Thonny in the description. You will also need a micro USB cable that can handle data. Many of the ones that are included with rechargeable devices do not. Finally, you will need the files that we need to transfer to the Pico. I'll leave a link to download them in the description, or they can be found on the Maker's Village page on the Diana Initiative website. Plug in the USB cable to Raspberry Pi Pico and then into your computer. On most devices it will open a file system window, as the computer will see it as a USB storage device named RPI-RP2. Go ahead and drag the MicroPython firmware.uf2 file onto this drive. This programs the MicroPython firmware onto the flash memory on your Raspberry Pi Pico. It should take a few seconds to program the UF2 file into the flash. The board will automatically reboot when finished, causing the RPI-RP2 drive to disappear and boot into MicroPython. Open Thonny, and then the file main.py in Thonny. Also under View, select Files to open the file sidebar used in this demo. Click the stop sign to restart the backend, or press Ctrl and F2. This will add the Pico to the file sidebar and create a serial connection. If you get an error message, check the serial connection in the lower right. Find the main.py in the file sidebar and right-click it. Select Upload to / and Thonny will copy it to your Pico. Next, click the Run icon or press F5 and the badge should start flashing the LEDs in the Lucky 7's pattern. This is a good time to make sure all the LEDs work. Press the button to roll the dice, and you will see that not only does provide the output on the badge, but you can see the output in the serial monitor. Click the stop icon or press Ctrl and F2. You can now disconnect the USB cable and finish the build, or watch the rest of the video where I will briefly break down the code. The first 3 lines are for importing the parts of standard MicroPython library that I used in developing the code for this badge. The next 20 lines are all the global variables needed, including setting the pins that control the LEDs to provide output and to listen to pin 3, which is connected to the button. Next we have our objects. Basically these are pieces of code that we can reuse, and most are for creating our pip patterns on the dice. Speaking of those pip patterns, the letter A or B and the number in the variable names match the designators for the LEDs on the badge. The last 2 objects are what actually control what numbers are output, one for each die. They are kinda iffy. Next we have our 2 loops that do the work. First the alt loop, it handles the Lucky 7's animation, while checking to see if we're pressing the button. Then our main loop, which handles the roll of the dice.